So in this video, we are talking about z-scores. Now, a z-score is the number of standard deviations a score is from the mean. So this first sentence is our definition of a z-score. Now, we've already sort of dealt with this indirectly before. In the previous videos, you remember we had our mean and then we just wrote using the standard deviation what each of the little kind of sections of our normal distribution was going to be using those two numbers. Now, a z-score just tells you basically how many standard deviations is it away from the mean. Now, a z-score, for example, of 0 indicates that the score is equal to the mean. So it's right on the mean. If we have a positive z-score, it means it's going to be above the mean. A negative z-score means it will be below the mean. Now, a z-score of 1, for example, just means one standard deviation above the mean. So if this was the mean here, a z-score of 1 would just be here. A z-score of -1 would be 1 below the mean. Now, the larger the z-score, ignoring the positive or negative, the further away it is from the center of the data. Further away it is from the mean, the middle. And that makes sense, right? If a z-score is 3, for example, it's pretty far from the mean. If it's -3 or even lower, it's further away from the mean. Now, we have a formula for calculating the z-score. We find this by taking our score, that's what x means, subtracting the mean, so figuring out how far away it is from the mean, and then dividing by the standard deviation. This will tell you how many standard deviations away it is. So it just gives us an easier way of representing how far away from the mean something is. Instead of using the actual scores, so writing in like we did in the previous video, like here I would have written, for example, 62 as the mean, and I would have had to keep going up by 11s because that's what the standard deviation is. This way we can just think of it generally in terms of a z-score. How many literal standard deviations is it away from the mean? Now, in this first example, it's saying for a normal distribution, the mean is 62 and the standard deviation is 11. Find the z-score for 84 and interpret this result. Okay, so what we're going to do is we are going to write in our z-score formula. So we're going to write our z-score equals to the score minus the mean over the standard deviation. Now, in this case, we're trying to find the z-score of 84. So our score is 84, our mean is 62, and our standard deviation is 11. Once you put this in your calculator, this will give you 22 over 11, which just gives you 2. Now, that means when it says interpret the result, this means the z-score of 2 tells us, the fact that the z-score is 2, it tells us that 84 is 2 standard deviations above the mean. So it's 2 standard deviations above the mean. Now, thinking in the same way that we did in the last video, let's just write this in how we did before and just check that this is actually valid. So we have 62 and we're trying to find out what score is 2 standard deviations above the mean. If we do it like we did in the previous video, we would just add 11 each time. So we would say, cool, that's 62. The next one's going to be 73. And then we add 11 again. That gives me 84. So it checks out, right? My score of 84 is 2 standard deviations above the mean. So you can always double check this, thinking of it in the same way we did in the last video to just verify your answer. Now in example 2, it's saying Ruby gained a mark of 70 for a class test. What is her z-score if the class mean was 78 and the standard deviation was 6? Answer correct to 1 decimal place. So we're going to write in our z-score formula once again. So that's going to be mark of 70. So 70 minus 78. Over 6. Now, already looking at this, you're minusing a bigger number from a smaller number. You're going to expect a negative answer, which checks out, right? Her score, her mark is below the average. So she's going to be somewhere on this side of the normal distribution. So she's going to have a negative z-score, we anticipate. So if you put this in your calculator, it gives you approximately negative 1.3. So her score is somewhere, if we have the average of 78 here, we have one standard deviation here. She's going to be somewhere around here, right? Let's actually just write in some numbers and just verify that this makes sense. So this first one's 78. That's our mean. Standard deviation 6. So the next one's going to be 72. So the score of 72 is one standard deviation from it's one standard deviation lower than the mean, okay? So this one's 72. If this were written as a z-score, this would give us -1. Now, if we go 6 down again, that would give us 66. Now, her score of 70 is somewhere in between 66 and 72. So in between 1 and 2 standard deviations lower than the mean. So we anticipate it's going to be negative, and 1.3, 70 is closer than 72. So it checks out that this decimal is going to be closer to this one. So her score is going to be roughly, let's say here. That contributes to a score. That's where you would roughly find a score of 70 on this normal distribution with these conditions. Now, one more thing just to kind of clarify our understanding. It's saying, what is the z-score that corresponds to a score that is the mean? So if the z-score is the mean, then if you substitute it into the formula, you're going to get a number minus itself, which gives you 0. No matter what the standard deviation is, that will be 0. So anytime the score is the mean, you are going to get a z-score of 0. Now, one standard deviation above the mean, that's going to have a z-score of 1. We've discussed this before. And one standard deviation below the mean, anytime it's below the mean, it's going to be negative. And it's going to be a z-score of -1. The z-score corresponds to how many standard deviations above or below the mean we are. But that brings us to the end of the video. Thank you so much for watching, and I'll see you next time.